welcome to ScienceHolic, first ever webinar in 2021. Today we are really excited to have invited Dr. Vicki Colvin, a professor from Brown University, to attend this webinar and be with us today. Welcome, Dr. Colvin. All right, so to Dr. Colvin, would you mind giving a brief introduction of yourself?
Sure. So yeah, I'm really happy to be here. I'm really, when I was in high school and thinking about what to do with my life, it was really helpful to talk to people who had made different career decisions. So hopefully I can be helpful to some of you on this call. So a little bit about me. I'm a professor at Brown University, and because of my interest areas, I'm in a couple of different departments. So I'm by training a chemist, but my research is really in biomedical engineering and even stretching a little bit more into pharmacology. I also work in areas of environmental applications because at the end of the day, I make materials, I make stuff, and we can do a lot of things with that. Before I got to Brown, I was at Rice University in Houston, Texas for 20 years. That's where I started my career as an academic. Before that, I was at Bell Laboratories, which was actually a corporate research lab. And then I was at UC Berkeley for my PhD, and my undergraduate degree is in chemistry and physics from Stanford. So that's kind of me in reverse. So I've been an academic, which means I do research and I do classroom teaching at major research universities. So universities that spend a lot of their time and energy creating the new knowledge of the 21st century.
All right, that's very impressive. Thank you very much.
Mm-hmm.
Before the webinar starts, I'd like to give a brief introduction of what ScienceHolic does as an organization. So we are a youth-run nonprofit that aims to introduce intricate scientific topics and in a manner that is fun and comprehensive to teens. Our main priority is to serve as a free resource for students to learn more about science topics, and we strive for our teenage readers and contributors to be critical thinkers and promote thought-provoking conversations. We also provide various opportunities for students around the world with English as their second language to expand their English ability. And we also finally provide volunteer and leadership opportunities to those who want to help others through our organization. One final thing before we hop onto the questions to the attendees, please send any questions you have in the chat. We'll try to go over them at the end of the webinar during the live Q&A session if they haven't already been answered in our already prepared questions. Now let's start with this general category of Dr. Colvin's profession as of course, a very multi-areaed professor. So Dr. Colvin, as you introduced yourself previously, your expertise covers many areas with chemistry, engineering, pharmacology, biotechnology. So what would you say is the focus of your academic and research career, and maybe you can talk about how you balance all these areas?
Well, it actually is really through teamwork. So it's not all me. I work with a lot of collaborators, but a lot of times how I describe what I do and actually how I train my graduate students is if you're a researcher, you have a core set of capabilities, which are things that you do really well and your students do really well. It's kind of like, what skills you might have, the technical pieces. And then the best and the funnest thing to do is to take those capabilities, which you research and you develop over time, and find ways to engage and collaborate and then use those in other areas. So you might envision a T where the bottom of the letter is sort of your core capability. And then the horizontal are all the different areas you apply it. So my group and my research's core capability is in making extremely small pieces of material, nanoscale materials. You've got a great image here. And those materials are not really molecules. They're a little bit big to be molecules, and they're not really solids like you can maybe knock on your table if you're sitting at one now. They're kind of in between, and they have really amazing properties. Because of their small size, in particular, they can get into the human body, they can interact with biological systems, kind of on the same scale that biology works. So that's one of the really interesting areas for applying the materials. And that's kind of my core thing, is how to make really sort of cutting edge unusual composition nanocrystals or nanomaterials, and then use those materials in biological settings, a human body, or in biotechnology, for example, to clean water, or even environmental remediation. And all of those projects we do in collaboration. So the core thing is the material, and then how do you apply it to solve problems in the world? So that's kind of a way that I think about what I do. So I'm definitely a chemist and an engineer because we have to make and control those materials. But then what we do with them is in partnership with lots of faculty and students in other areas who have problems that need solutions.
All right. So with so many STEM fields as your expertise, what sparked your interest in the STEM field in general and inspired you to pursue a career in this field? And is the career path you've taken what you envisioned yourself being in during your teenage years? This was actually like a combined question with one of the questions and one attendee submitted through our registration form. So I'm sure we're all very excited to hear the answer.
Yeah. So when we know when you're a teenager, how do you know what you want to do with your life, right? It seems like a very long time ago, but it seems also like yesterday, actually. So, I was fortunate to have a parent, my mother, who is a scientist, or she's a science educator. So I grew up with a family that knew a lot about STEM. And what was pretty clear to me, I think, when I was sort of in junior high, was that, quite frankly, I liked STEM because when I was a teenager, I would turn in essays in my English classes, and I would sometimes, get a B, and I would say, well, why is this a B? And they were like, oh, it just wasn't compelling. And I would turn in a math test, and if I got something wrong, I knew exactly why. So I think I tended to like things being black or white. So, and I also felt if I had that knowledge of STEM, I could use it to change the world. Like if I created a new molecule that could treat, and, make pancreatic islet cells produce insulin better, then that would help people who had diabetes. I could see a really clear connection between scientific knowledge and improving the world. And I didn't see that connection in the other areas. So for me, that was it. And I also just I'm very curious, and I was curious as a kid. So I like sort of figuring stuff out. And my curiosity and my questions were kind of in all areas, but in science and in STEM, I felt I could answer them really clearly. So in some weird way, I was a black or white kind of person. I've changed actually a little bit since then, but certainly as a teenager. So I appreciated STEM for that reason. I also, I like to do logic puzzles. I like to think through things in a very sort of maybe technical way. And that was pretty obvious. But I also really enjoyed reading, and I love to write still, big part of what I do. So, it wasn't an easy decision, but that's definitely what did it. I think my inspiration really was, I think I saw a graph when I was like a junior in high school that showed the number of people who live on the planet. And it sort of did this huge jump right around, the late 1800s. And I remember asking the teacher, the lecture was all about how the development of agriculture and then later the development of antibiotics really made it so people didn't die because they had better food, they were organized better, they didn't get as many diseases. And that's really what sold me, that I'm like, okay, I can have an impact on the world and on really making it better if I do STEM. So that's actually what propelled me to do it.
All right.
And I didn't ask the last question. Is it the path? I would have guessed. When I was in high school, I ended up with choosing chemistry, because with chemistry, you can do anything. And in high school, that wasn't my favorite science. I love biology. But then in college, I just found myself more drawn to chemistry and physics. It was the classes, it wasn't the teachers. I think in high school, you tend to like subjects that have great teachers. And by the time you're in college, you've seen it enough and you kind of know what you like to study. I actually looked forward to doing my physics homework and my calculus problems. It was like fun for me. And I really started to dread memorizing all the terms in biology. So that kind of dropped me into those areas.
All right. It's always been like a pressure for high school students to have figured out what they want to do in life. So it's always
It's
kind of
very hard.
yeah.
And, you know, I advise a lot of students at Brown, freshmen, you know, a couple years older than some of you. And, you know, there are two types of kids, I think, people probably. Some people are very focused and they knew when they were 4 years old what they wanted to do. And they're just, and other people are always questioning and wondering, is this the right path? Is this what I should be doing? And they have a, you know, and they're always going to be like that. You just sort of have to accept that if you're one of those people who I call sort of a path maker, you're just always going to be questioning and maybe shifting paths, and that's okay. So there's a lot of different people in the world. There's no one right way to be. So some people really do know early and they're very, very, that's all they do. And other people are kind of exploring all the time.
All right.
Both of those things get you to the end goal.
That's a relief to hear for many high school students, I believe.
Yes, yes.
To address a little bit about Brown University and its STEM fields, how is your research conducted at Brown University labs, and how do students, perhaps undergraduate and graduate students, contribute to your projects?
Yeah, great question. So first I'm going to define research because I think that it's hard for students to know what that means. And my definition is pretty simple. It's the creation of new knowledge. So it's a very creative process. It's not like being in a class. There's no textbook. You don't know what's going to happen. And you're literally creating new knowledge. You might be also creating new technology in the process, but at the end of the day, you're creating new knowledge. And that's really what you do in a research laboratory or computational or experimental. So when I have a laboratory, so I'm a professor. And so you know, it's funny when you hear the word professor, you would think most of what I do is kind of like I teach, and I do teach in the classroom, but it's a small part of really what Brown wants me to do. A lot of what Brown wants to do is, you know, create new knowledge, make sure its faculty are leading the world in their areas. So what I do in my lab, creation of new knowledge about nanoscale materials, about how to apply them. We have graduate students writing a PhD thesis, and that process in the United States, it differs in different countries, takes about 4 to 6 years. The average PhD is about 5 years. And during that time, the students are actually paid. So when you go to the postgraduate, they're kind of like, sort of like employees. And they all work in my laboratory, which I fund through asking people to fund my research, different agencies and foundations. And that pays the graduate students to work in the lab, and they write papers, present conferences, help me write proposals. They do all of that stuff to get really good at creating new knowledge because it's a skill. And so undergrads, it's so funny you would ask, we just started this semester at Brown, and I teach the large chemistry lecture first semester. I actually didn't this year because I'm on sabbatical, but I usually do. So I get a lot of contact with a lot of great students. And those who get really into some of the subjects I cover in lecture can come do research for me, and they can do it for credit. I have about 5 people taking research for credit in my lab. So they work in the laboratory with a graduate student. So I actually don't go into the lab very much now. I'm more of the writer and the thing, you know, I put the papers together, I get the money in, I do some experiments, but really the hands-on people are my graduate students and postdocs. And they work with the undergrads, but then we also meet as teams to kind of go over their data, talk about what it means, plan the next experiment. So it's kind of a joint effort between myself and the graduate students to mentor undergraduates. So they'll do independent study, which lets them take a slightly lighter load than you would find normally. And that can be advantageous. And then that can lead to writing an honors thesis, which is an option for many Brown majors. And then many of them will do summer research with me, which is really when they can own a project and potentially be an author on a publication, which is kind of as an undergraduate, should be your goal. If you want to do STEM and you want to get into research, it's really less about your GPA for most graduate tracks and more about your research experiences. So it's really important for undergrads to find the time to do that and make sure they like it. Research isn't for everyone. So yeah, I love to work with undergrads and grad students because we get a lot of diversity of backgrounds. My projects need a lot of different types of people. So with the undergrad piece, I can kind of get really, really powerful teams put together.
That's very cool. I never would have thought that graduate students would also coach, not coach, but like guide undergraduate students.
Oh yeah, well, they're the ones who work in the labs. Very rarely will you find a professor. You can sort of think of it like I have a business. I have like a small business called Colvin Research. And I spend a lot of time funding that. Brown doesn't pay for that. I mean, Brown gives me the space, but I have to pay for the research. So I spend a lot of time finding customers for my research and writing to people about it and kind of managing my business. And the graduate students are the workers. They're the ones who are they're taking the data that goes into the papers. And I'm teaching them how to put that together. How is it you get a result of an experiment and then build a scientific argument and make it a really strong one? And then how do you literally communicate or market that to whatever community you want to? So that's kind of what they do during their PhD.
All right, that's very cool. And talking about general career, but is there any one specific experience throughout your research or teaching career that you find particularly rewarding or memorable? Or like another version of this question would be, what's your favorite parts of working in STEM or with students?
Well, it's funny. I just told you I didn't work in the lab, but some of the happiest days. So I will tell you about one really specific memory that might be one of the happiest days of my life. And it's more about why I love research and why I like to introduce research to people, because it's a huge privilege to be able to create new knowledge. So I was a young professor at Rice. So this was probably before some of you were born. It was about 1999. And I was using something called an atomic force microscope, which has like a little stylus and it taps on surfaces and it lets you see the topography on the nanoscale. And we were really interested in studying how, I'm going to use chocolate as the example, but wax also. How does chocolate melt? So you heat chocolate up and it goes from being a solid to a liquid, right? But the question was exactly how does that happen? Does the whole surface turn into a liquid, or do you get like a little island of liquid that then grows? How does it actually happen? How does that phase transition occur on the nanoscale? And in order to answer that question, we had to build a heater. So the microscope we were using cost a couple $100,000. It was shared. And I had an undergraduate, actually, Steve Perliman, who's now a professor in Oklahoma. And he spent like 8 months of his life constructing a little tiny heater that fit in this very complicated microscope that allowed us to heat samples in the microscope and study this question. And I remember we had so much trouble because we would heat and then the microscope would drift and we could never get data. And Steve worked and worked and worked on how to insulate it. And we were there really late. It was like 1 a.m. and I was sitting there with Steve and all of a sudden it started to work. And we actually saw how, in this case, chocolate melted, and it melted, actually, it looked like a bunch of little pimples forming all at once, and then they grew and merged together, which is actually important, although I won't go into it now why it was important. But I remember the moment where we knew we had fixed this problem that literally he had spent months working on, and we didn't know if we could fix it. We weren't sure it was possible. And that moment, and then seeing all the data, it was a really beautiful project and very fundamental in nature. So yeah, that was a great day in research for me. And it also was a great day for him, right? It hooked him on doing research because it's a very exciting thing to do. There's a lot of drama. There's a lot of, challenge, mountains you have to climb. You're not sure you can, but when it's successful, it's incredibly rewarding. And that was a day where all of that hard work had paid off in that moment. And I think in teaching, it would probably be, and this is the little moments when I'm explaining the intricacies of how to do some buffer problem to a student, and I hit upon the right way to explain it, the one-on-one with a whiteboard and a couple of students. and then they get it. They get the way I'm explaining it. And then I know that like they'll have that for the rest of their lives. So it's when I see that aha, that I've explained some really tough idea, but I've really gotten something to the student that they're going to use, that I feel really, it's great when you teach and you see that. So those would be my two examples.
It must be so nice to know that hard work paid off and your students replicate your happiness.
Yeah, it is. It is.
And moving on to more general stuff, though it's still related to STEM, of course. What does your typical workday look like?
Good question. Well, with the pandemic, it's really different. This is my office. So a couple of things I would say about that. I typically, in fact, I started to use an app called Rescue Time. My daughter, who is a sophomore in college, sort of turned me on to this app, and it sort of tells me how long I actually spend at this desk working on my computer. And so a typical workday for me will start 8 a.m., 9 a.m. I live very close to my campus, so I don't have to commute. If I'm teaching, I would teach about twice a week. So I'd have 2 lectures a week, and I'd have some office hours. So I usually like to teach in the morning. So I might have to get up and teach a lecture. If that's happening, I'll be up an hour and a half before to make sure I know what I'm going to say in my lecture. And I think hard about the presentation. That's particularly true in large lectures. I may lecture 200 or 300 people. So if I'm going to do that, I try to make it worth their time and be kind of an entertainer. So I like to review. So I'd give my lecture. It's a very varied day. So I'd be standing up in front of a big audience for an hour or even an hour and a half, depending on the class. Then I would spend a fair bit of time managing, like I said, it's kind of like I run a research business. So I have to deal with a lot of, little things. Paperwork might consume an hour or so, responding to emails. Then I meet with my students, my graduate students. We have a schedule. I have about 8 of them now, and I meet with each of them every other week. So I might spend 4 to 6 hours in meetings, and I will have prepped for those. So if I have an hour meeting with one of my students, I'll spend at least an hour at some point beforehand, kind of thinking about what I want to accomplish, where they're at. So I spend probably a big chunk of my time talking to my graduate students. And we also have group meetings every week where we talk. A lot of how you learn really complicated science, believe it or not, is talking. It's so funny. When I was in high school, I thought science was like you'd be all by yourself and you wouldn't have to deal with people. And that's not true. Actually, it's a very social process. So group meetings and learning hard stuff, you have to do that one-on-one. And so we spend a lot of time doing that with the students. Then probably I chair a department, so I have an administrative role. So as I've gotten older, I've taken on, you can think of it kind of like being a principal, maybe a little bit. So I have to do some of that work, which I like to do for different sets of reasons. And then really if I'm lucky, one of my goals right now in my time is to spend at least a third of my time literally writing or doing things that help me write. A lot of what we do as scientists is communicate our findings. And we also write proposals to ask for money. And those are both very writing intensive activities, although it's not really like I'm writing. It's more like I'm thinking about exactly what I'm going to say and what my arguments are. So it's called rhetorical writing. And probably most profs, if they're being honest, should be spending at least a third to half of their hours on that. So that is generally a solo activity. So then I would be by myself at my computer screen, but I wouldn't just be writing. I would be reading paper. I have like different things I do when I pull a paper together or a proposal. I use like 4 or 5 different types of things. And it's a very creative process. And it's a lot of iteration and revision. And so then, I have kids. One of the things I like to tell at least young women is that being an academic is a great job because you have a lot of freedom. So I usually get home in time to have a family dinner. Of course, during COVID, it's like family all the time. But I have a teenage son who's a 10th grader. And Actually have a couple of Chinese exchange students now, which has been really fun. So we have a full house of teenagers, and we have a dinner. And I cook about half the time. My husband cooks the rest. And then depending this time of year, I'll probably work another hour or two. I actually like the evenings. It's when I can do some of my best writing. So if I've gotten a good night's sleep and taken care of myself physically, I usually do work out in the morning, then at night I can sort of sit here in front of my computer and work on the writing, and have that quiet time to really think. So that's kind of my life. Now, I would say without COVID, the other big thing people don't realize about researchers, like I said, we have to learn by talking. I was on the road probably 2 to 3 months out of the year. So travel was a big part of what I did. So that comes with being a researcher. Not in all fields as much, but certainly in the US and the fields that I'm in. So maybe it was a month or two in the last couple of years. So that's a chunk of time too. So those are my days. So I might be traveling to some interesting place. Usually it's Washington, DC.
All right. That's so insightful. One day must be so busy for you.
I see what the high school kids are doing here. I don't know. It's busy for all of us. If you love what you do, though, you want to find something that you really want to do. You're either challenged by it and you really want to do it, but it's not a drudge. Some days there are things I don't like. Like I hate paperwork. But it's part of my job and I have to just do it. So I try to do it. But you have to find something you love to do. You have to find that. So
that's something we all want to have something we love, so that work becomes play.
Yeah, and it gets you over the stuff, because any job you're going to have things you don't like to do, but you have to be able to you're mature and you're like, okay, I don't like to do this part of the job, but then there's all this other stuff I really do like to do. And so you got to pay close attention. And funnily enough, when I was in high school, the stuff I really liked to do, the kinds of assignments I enjoyed, were all about figuring stuff out, like trying to understand something complicated. And that's sort of what I do now, actually. So I was right in the sense that I did pick a career that I liked when I was a teenager, a piece of it at least.
All right, that's very insightful. What do you think, in your opinion, what kind of student would be a good fit for studying chemistry, engineering, and/or biotechnology subjects?
Well, I'm going to tell you what you shouldn't worry about, and this is maybe counter to some advice you've gotten. And I'm really going to answer the question for a research track. Like if people are thinking, I'm happy to talk about medical school and pre-health and other directions, but I'm thinking about becoming a STEM professional, like researcher. And it doesn't actually matter that you're an A student. And it's funny because what I've learned in my career, both in my own experience and experience with a lot of students, graduate students, undergraduates, is that the skill at really, being good in a classroom and being able to master a standardized exam is a measure of something. It's not important, but in research, it's more about how deeply you learn and how curious you are and how complete your knowledge is. And what I've discovered is that students have to be good enough. A lot of times students want to choose something they're really good at, which I always dissuade them from. I mean, you have to be good, you have to like to do it. But I think students who are really curious and who like and are comfortable if things aren't known, like if we really don't have the answer to something and that makes them excited, then they're the kind of people who should stick with STEM. If they're curious and passionate and it's something that really fires them up. And be aware that one of the things that's kind of tough about grades, which is a super huge part of your life as a high school student, I know, is that you have to learn something, but you're given a really short period of time. So in a funny way, I took calculus like 3 times, not because I flunked it, but I took it at the local college when I was really young. And then I took it again in my high school. And then I took it again when I was at Stanford, some version of it. And the funny thing about it was I actually learned it better each time. And so what I realized after that experience is, if I had only taken calculus for 3 months, I wouldn't have really known it. And I think that's true of research. It's more about how deeply you can learn and hang on to the ideas. It's not just that you got an A in a 3-month class with calculus. It's like, do you remember it 3 years later? Did you really understand it? That's what's going to matter. And so that skill, some students, it might take them a couple of times of seeing a subject in a different context for them to really get it. And that's true with, some really tough ideas in chemistry and in physics, but it's really remarkable. Like, you hit a subject that you think is so complicated, like you'll never know it or grasp it. I remember there's something called group theory in inorganic chemistry, which is very abstract. It's a very, very abstract set of ideas applied to molecules and how to classify them. And I remember when I first learned it, I was like, oh, like, I will never understand this ever. I'm just going to try to mash the equations around and get the right answer. And that didn't work. I didn't do great. But then I saw it in a couple of other classes as I was developing as a chemist. And then I really got it. I really got it. And sometimes it just takes that kind of time. So curiosity, persistence.
Curiosity and persistence. It's less number-based than.
Yeah, don't think you have to get A's. So many students, and it's interesting, the ones who go into graduate school are often not the straight A students. And so as long as you have to be above a threshold, you have to be able to perform, but you don't have to be the best in your class to become an outstanding researcher. The skill in a classroom is very different than the skill you need in research. It's somewhat related, but pretty different.
Okay.
If you're a musician, I bet I have some musicians on the call, I'm guessing. I was a musician. I am a musician. And so I play the woodwinds. And so, there are people who can practice their scales, right, and do them really fast. And that's important. But what makes somebody really good at the instrument is a whole bunch of other stuff, right? The scales are just a piece. And that's a good way to think about the classroom.
That's true. I've never really thought about it that way. But thank you for that. It's really insightful. And considering that you are a female professor, do you see a disparity between male and female students pursuing STEM fields or as professionals in STEM?
Well, certainly the numbers tell us there's a disparity. So the statistics on certainly engineering and all of the physical sciences, biology not in the same grouping, is very clear that at the undergrad level, graduate, the PhD, and certainly at the professor level, you have what's called a leaky pipeline. The number of women that are in the profession drops at each of those stages. So what I observe is that so there's sort of two answers to the question. Because I'm a female STEM professional, I get a lot. Probably my group has always been half women in my PhD population. So that's not unusual. As a female mentor, I tend to get a lot of female grad students. At the undergrad level, what I see is, women are, you have to be persistent. You have to say, wow, I got a B in this chemistry class, but I still really want to do chemistry. You have to kind of be able to believe that the grade is just the grade and it's not actually you. It's not saying something really foundational about your abilities. It's just that class, that situation. And I do think that broad generalizations here, female students tend to take it more to heart and think that they can't do it if they don't get signaled perfectly at all times. And eventually, in any career path, as you get better and move along it, eventually you're not going to be, the top of your class. And so you have to be able to manage what that means. And what do you tell yourself? What do you think when you get an 89 or a 75 on a test? And, there's a lot of psychological literature and other literature that suggests that people who are not in the majority population take that information and have thoughts about it that are not effective thoughts. Thoughts like, oh, I'm really bad at chemistry, or I'll never be able to understand this, or I give up, right? I will never, those kinds of thoughts are not useful thoughts and probably also not true. And I think that's where we need to intervene and hear other people give you other thoughts to think when that happens. So you don't sort of, make too much of it. And so, yeah, I do think that there's some gender issues in that arena, particularly for young adults, probably throughout their career. And it's really unfortunate because, we all know that a diverse workplace, having lots of different people with lots of different backgrounds, leads you to solve problems better. I mean, that data is also very clear. So it's a problem we really do have to fix, as a society.
That is true. But I'm sure with the future, there will be a better gender equality when it comes to the STEM
Yeah, I
fields
hope
and all that.
so.
And this final question of this category, what advice would you give to high school students who are considering a career in STEM fields? Or you can make it more specific as to a research career or, the areas that you're...
Generally. Well, one thing I will say is don't be freaked, take your math, force yourself to take math. Don't be freaked out if it's hard or you don't do well, but math is going to be really essential for a lot of the STEM fields. And the interesting and cool thing about the high school math, like I said, I had calculus more than once, is I would strongly encourage students who are going into STEM to actually retake things they may have AP'd out of, because you really learn it better, especially if you think you're going to go in a direction that you need it. So that's my first piece of advice is pay attention to your math. Force yourself to do it. Some students don't like it or they have trouble with it, but it does get easier as you get further along, I think. And consider, if you have the time and space in your schedule, to not APing out of everything and jumping in college to where you might be placed, but sort of falling back and really getting a strong foundation. Some areas of STEM, you build a foundation knowledge, and then when you take a class, you have to have the knowledge that came before, right? And it stacks. Chemistry is a lot, chemistry and physics is like that, biology a little bit less. So if you didn't get the foundation, you're really out of luck because you can't do those higher classes and you'll always be in a deficit because you don't have that core. And math is one of those areas which is very much like that. So if you're weak in any way or you forgot it or it can't be really fast, it's not at your fingertips, you're not fluent, that could kind of hurt you as you progress in math. So math is the one that I would suggest. Definitely take a lot of it in high school. And when you get into college, if it's in your path, maybe fall back a little bit and retake some things you saw in high school. So that would be one piece of advice. The other piece of advice is do what you can to get into a research lab. It's really hard to take high school students into labs now because of safety issues, not just COVID, but before COVID, we had a lot of problems because students, if they get injured in a lab, it's a very big problem. So most universities don't allow that anymore. But you could always do a science fair project. I'm a huge fan of science fairs. If anybody out there has a science fair project, needs a coach, email me. I've coached a lot of students in science fairs. I did it myself when I was in high school. You need to sort of get a sense of what does it mean to create new knowledge? Like, what does that look like exactly? And I think that, finding a way to do that would be good. So those would be my two pieces of advice. Think hard about your math and think about getting some experience with research early because you might find you really love it and then you'll know you want to do it.
All right. So now we're approaching the attendees questions that we've received from our registration forms. And after this, we will move on to the live Q&A session, which are the questions that have been coming in, trickling in the chat. So we'll start with these first.
Great.
So this question is paraphrased slightly, but a attendee says that he or she is struggling to choose a career path, but is interested in chemistry, physics, and technology. What advice do you have for students who have no idea what path they should pursue in college?
Right. So if you're STEM, so you've ruled out the non-STEM, great, you've closed a door. So my advice is focus on closing a door. Things you don't like. Sounds like the students decided, okay, biology isn't for me. Great, you close the door. You can always reopen it, but for now, so if you sort of have some knowledge that, like I did, like I didn't like memorizing biology, so I'm like, okay, I'm not going to do biology. Although, funnily enough, I do it now. But so pay attention to what you don't like, and try to disentangle the teacher piece. Then if you don't know what path you should take in college, most of the time when you show up in college, depends on the college, you maybe have to guess what your major is going to be, but you can always change majors. It isn't the end of the world. And I tend to say more quantitative. So let's say you like chemistry, you like physics. I liked both of those. And I also liked engineering when I started, right? I liked everything. You can tell I have a broad set of interests. So I liked everything when I was 18 also. But I had to choose. And I had a really good advisor who said, don't freak out. It's not important exactly what you choose, but that you choose. And it was good advice. And so I was like, yeah, okay, I'm not going to stress about exactly what I'm going to do. I'm just sort of, well, I like chemistry. I'm going to keep doing chemistry. And it was sort of happenstance that sort of led me there over engineering. It wasn't like some conscious choice. And once I sort of got less freaked out about making like the perfect decision for me, I just talk to people, go to webinars like this. My mother knew people, I talked to professors, and I sort of got a sense that, yeah, I was a little bit more of a scientist than an engineer in my tendencies, especially at that age. So, then I became confident in the decision. And so, if you like STEM, my other piece of advice, if you like it and you really can't decide, the more mathematical direction, so engineering, physics, is usually easier to step away from. So if you choose a path in biology, it will be very hard to step into physics and engineering because you won't have the sort of foundational math and increasingly statistics experience. But if you choose physics and engineering and then you decide you really like biology, there's some paths for you there. Maybe not as a biologist, but stranger things have happened. So I would tend to kind of go more quantitative just because those are going to be very difficult to pick up later if you change your mind.
All right, so that's very good advice. Thank you very much.
Mhm.
Another attendee asked, what kind of research were you
Ah,
involved in at the AT&T Bell Lab, I believe?
yeah, I loved this. So sadly, there's really not a corporate lab like this left anymore. So it's where the computer was invented and the laser was invented at AT&T. So by the time I got there, it was an amazing place. So I actually worked on holographic materials. So like the Google Glass, or the idea of being able to see stuff right in front of you from glasses or on a window shield, those are holograms. And I worked on the materials that let you encode holograms. And it's super cool because if you see an image, one of the coolest things I did is with my, again, collaborators, is we had a chunk of polymer. It looked kind of like a thick piece of plexiglass, and we had encoded in it holograms of a cartoon. And the cool thing about a hologram is when you've encoded it and you shine just the right laser beam on it with the right frequency and right angle, over here, you get the projection of what you encoded. So you see it sort of floating outside. And then as you rotate the plexiglass, you see the object move. It's the coolest thing. Really, really cool. And so that's what I was working on at Bell. And it was interesting because they spun off a little tiny technology called InPhase. And that actually got bought up by Microsoft. So some of that core technology years later now is maybe going to go into the Google Glass and not, I forgot what the Microsoft version of it is, but that's what I worked on.
That's very cool. I'm seeing that there's a couple of questions in the chat and that we started kind of late, so we might go slightly over time today. I'm very sorry.
Totally fine.
But
I'm all yours.
this is a question that's kind of elaborated, but the attendee asked, how do you work and study and manage your time efficiently? And I see that in the chat, there's also a similar question asking about, let me pull that up. How do you balance your time between work, studying, and for high school students, extracurriculars, competitions? It's quite a stressful experience.
It is. I know. I'm so glad I'm not a high school student now. Yeah, so let me take the high school question or give you my advice on it. So I think it is important and high school is kind of a special time. I'm sort of glad that you're asked to be a Renaissance people and do a lot of different things, because most of the rest of your educational career will be about specialization. So you have this really unique opportunity right now to kind of have a couple of different things going on, but don't sacrifice quantity, do quality, don't do quantity. So it is really important depending on your aspirations. But if you want to get into a very competitive college in this country, then they're gonna look at your application beyond your grades and beyond your standardized exam scores. And I think that what matters more is that you show initiative and leadership, and or just a long-term passion, and that you have to really like those extracurriculars. You can't just be trying to check a box. And so I think they look for, and I look for, when I talk to students here at Brown's pretty competitive, and I meet and advise a lot of our freshmen, and I can tell the ones that really just were box checking in high school, just trying to resume build. And they get to Brown and they kind of, they go off and do maybe something completely different or stay totally focused on only one thing. And others, like I can think of one of my advisees last year, he's going off to med school. In fact, I think he's in now. And he was a really talented pianist. And he struggled with balancing piano and these really intense pre-med. He was an engineering pre-med, which is very tough path. And I told him, I said, eventually you're just not going to be able to practice 10 hours a week. If you want to be a doctor, you're going to have to, it's not that you're never going to do it. You're just not going to do it for the next decade. And you'll, have a piano and play it every once in a while, but you're not going to be competing at the same levels you have been. And you have to do that to provide the time and space for other stuff. So I think that you have to be kind of aware that there are times in your life for all kinds of different things to happen. And in high school right now, you have a chance to explore some of these non-STEM, these other passions and interests that you might have. And that's actually cool, but don't think that you need to do too many things. I think that they see right through that. Try to stay true to who you are as best you can. And as far as what I do now, as I said to you, you're not going to change if your 50-year-old self were to come back and talk to you. You're not going to be a completely different person when you're 50. So when I was your age, I played clarinet. I was doing high school science fair. I had to work. I had a busy, complicated life. I had to juggle. A lot of times I dropped commitments and I felt really bad about that. But the reality is that I'm not that different now. I may be a little bit better at it. I'm better at sort of recognizing what I can fit into a week. But I have a lot of interests and I'm pretty high energy, so I just do them. But yeah, it's an ongoing thing. It will be a lifelong process. It's like you're not going to hit some nirvana and ding, you'll know how to balance it. What I would say is with new technology, it's amazing. So one thing I will say is I evaluate myself, and I've always done this, like I study myself. So I've always looked at, gee, I had a bad week. Why was that? Or like today is my evaluation day. So I was looking at what I did over the last week and I was calculating. A big thing I've been working on is my sleep in COVID. I'm naturally a night owl, so I've been staying up later and later and later, which is not good. So, I evaluate myself, and I'm not in a bad way. I try to be very compassionate with myself, but I try to understand. I get curious about, why did I have a bad week? Like, why did I put that off and end up having to work nonstop on only one thing for a week, which means I got behind on everything else. So I learn a little bit every week. I have been for many years. So I'm slowly getting better at it. But I would definitely say, look at your weeks, pick one day a week, and don't get on your case. You have plenty of other people getting on your case. You should be very compassionate with yourself and be proud of what you're able to do.
Thank you for that. And this question, I know we kind of already addressed this, but one of the attendees asked, have you ever faced sexism or like discrimination as a female being a woman in a primarily male-dominated field?
Yeah, I mean, it's hard to know. Yeah, I mean, I'm not going to give an anecdote just because I think it's hard to know, all of us have struggles, interpersonal struggles with people, right? And it's always a question, what is sexism? But I will say, certainly, as I noticed this much more in physics than I did in chemistry when I was an undergrad. It was a cultural thing about the physics program I was in and the department and the other students. And it was really hard to join a study group. So, like I said, you learn by talking. When you get into really complicated, hard subjects, you have to talk to people or your brain is not going to learn it. And it was really weird and awkward to train myself to kind of, ask and be assertive, because if I was like one woman in a class of 30 in physics, and it was awkward to try to find somebody to work with. It was much easier in chemistry where there were 3 or 4 women. So I sort of didn't. I tried to find other ways to deal with that. And I probably would have done better if I could have overcome that. Later, I learned in graduate school, because I had that, you go to a conference and you're like a handful of women and there are hundreds of men and they're all schmoozing at a mixer. It's awkward to go and just, you feel very self-conscious if you're the odd person out. And what I learned to do was, especially with older men, to always ask about their daughters. Like, oh, do you have kids? Do you have a daughter? Because usually their daughter was close to my age, or once they thought of their daughter, they could interact with me and we could talk about the daughter, and then I could talk about science. So I learned coping skills for that. And then for sure, and I didn't do this enough when I was younger, there's this tendency, I don't know if you've heard of it, but it's called the queen bee tendency, which is that if there are 2 women in a large class of men, or 2 minorities of any type, however that works, they tend to be competitive with each other because by association, they highlight their difference. It's very interesting psychology. And so what I wish I had known that when I was younger and fought against it harder. I fight against it now and I seek out women and I work, I really try to not let that be an issue in my own sort of community and setting now. But when I was younger, I didn't understand why I didn't want to work with the other women around. Why did I sort of shy away from that? And now, I understand that better. So that having that knowledge has made me also counsel and advise younger women to say, look, the women are going to have your back. So make sure you make alliances, and reach out to them, because it's going to ultimately, those alliances will be very strong ones for you.
Thank you for that. Mm-hmm. Now we move on to the live Q&A questions. I see some questions in the chat that's been trickling in. So Peggy asks, which one would you say is harder, organic or inorganic chemistry?
Well, for me, that's easy. Organic was really hard. I am, the interesting thing about chemistry, Peggy, is that it's a beautiful subject because it's mathematical in some parts and very conceptual. It's almost like organic chemistry is kind of hieroglyphics, right? It's a totally other kind of language. And it's very language based. It's very totally different in how you learn it and the kinds of skills you need cognitively to master that. So interestingly enough, if you develop as a chemist, you're going to find that chemists really track very early into 2 camps. Those who really like math and love to work with calculators and like inorganic chemistry and physical chemistry. And then those who like organic chemistry and like biology and medicine, right? There's some people who are good at both, but usually there's a strong tendency to one or the other. And I'm definitely in the quantitative camp, which means I found inorganic easier. And it's certainly more reflective of my research now. We work with the whole periodic table, not just carbon. Although, in research, when you go and learn organic chemistry, I'm learning, and then I'm fascinated and I learn it and it's great. So I learn pieces of it. But yeah, I could maybe teach it, but it would take a lot of brushing up. So I thought inorganic was easier. And I think Gen Chem is easier than organic.
All right. And Kayla asks, could you talk a little bit about the biomedical engineering aspect of your career? How do you get into the field, and how would going to medical school benefit someone who is hoping to go into that field, venture into that field in the future?
Yeah, great question. So I, over profs are defined a little bit by our disciplinary identity, which is what degree did we get as an undergrad. So I am definitely a chemistry and physics undergrad. And I didn't even take that much engineering. But when I started to do research, remember way back in high school, I liked STEM because it could solve problems, right? Well, guess what? I had a science background, but I wanted to solve problems. That means I was going to do engineering. So with Bell Labs and a lot of the stuff, I started to drift more and more into engineering areas, applied sciences and engineering. And so I kind of landed in engineering. And one of the things that I sort of defined the early part of my career was an interest in how biology recognized and interacted with nanomaterials. Like if you're a cell and you see a nanomaterial, what is it? Like, what's the cell going to do? Is it going to eat it? Is it going to ignore it? Is it going to die? So that drove me to build biology into my group and get funding in those areas. And that actually then led me to collaborate with clinicians who had problems like, how do we take an MRI of a liver and know if somebody has fatty liver disease, for example? And so as I started to work in those areas, I started to publish in biomedical engineering papers and journals, and I got asked to teach in that space because nanomaterials were becoming really important in biomedical engineering. That was, so my area was sort of invading biomedical engineering, which traditionally was organ replacement, like an artificial heart or something. Nowadays, it's much broader. So I sort of drifted into being part of that program, part of chemical engineering, because of the kinds of problems I worked on. And when I moved and I came to Brown, I made that shift very directly. And I said, okay, I'm a biomedical engineer. I'll teach in BME. I'll advise students in biomedical engineering. So I know a lot more now than I did 5 or 6 years ago about the field. So it's a great field. And a lot of the undergrads at Brown who are biomedical engineering majors go on to medical school. So when you ask about medical school, there's kind of what do you do before med school? Then there's med school, and there's what do you do after med school? So biomedical engineering is a great path for someone interested in med school. The downside, depending on the school, is just engineering concentration majors have a lot of requirements. And pre-med has a lot of requirements. So you have to make sure that works at whatever institution you end up at. But they usually do spectacularly well when they apply to med schools because they have a very different background than your average biologist, right? Usually a BME, that's what we call it, biomedical engineering BME student going to med school is going to be interested in the sort of newest innovations in technology and medicine. They're going to be the people who are trying to figure out how to make a better, suture material, or how to keep, the inline catheters from getting infections. They're going to be working and thinking of solutions to clinical problems. And a really good program would give you a sort of experience in that before med school. So it's a very good thing. And after med school, then a BME background would lead you to things like radiology, which is very instrument intensive, very quantitative. Certain subspecialties of medicine might be more aligned with a background in BME. I have a very good colleague, friend of mine, Lee Hochberg, who is an undergraduate biomedical engineer and an MD PhD. His PhD was in engineering, and he is now he's a neurologist, but also a neural engineer, somebody who implants stuff into people's brains to, cure disease and to, it's amazing what they can do. And so that's an example of sort of the engineering medicine mix. So it's definitely, if you're an engineer, though, you gotta like to build stuff. You gotta like to think about concrete devices and that kind of, because that's part of your undergrad training. But yeah, it's a great area and a very broad one now. Biomedical engineers like myself might be making new types of medicine, new types of imaging agents. Then you'll have people, I have a colleague who's literally building new types of hearts to, cure heart attacks, repair the heart, all the way to Lee Hochberg and the neural engineers who are doing things like, treating depression with deep brain stimulation, which is actually a device that's in the brain that you activate from afar. It's really science fiction-y stuff, but it's happening now. So it's a great area, very broad.
That's so insightful. I never knew a biomedical engineering major can do so much.
Yeah, it's cool. You do have to like engineering, right? The first year or two, you're taking a lot of engineering classes. You'll learn mechanics. But on the other hand, our biomedical engineers here at Brown, they take a third of their classes in biology. They take immunology, biochemistry, so they get a lot of the core curriculum that you need for medical school too.
All right. Seeing as the time, we're a little bit over time, I think this is a good time for us to end the webinar. I'm sorry for the abrupt end, but thank you so much, Dr. Colvin, for
Thank you. It was fun.
this hour with us today. It's been incredibly fun, and your answers to the questions have been really insightful and helpful. I'm not sure, not only to me, most of course, but also to the attendees, I'm sure. And thank you to the attendees for attending this webinar. On this screen, you can see some of our social media platforms, such as Instagram and Wechat, on which we are the most active on, and in our email if you have any questions about ScienceHolic as an organization. And on the right, you can see the link to our official website. And we are recently collecting donations in preparation for our upcoming winter edition, seasonal edition of our magazine. So it'll be wonderful if you could donate to us and help us. And yes, thank you so much, Dr. Colvin, and thank you to the attendees. Please expect an email with a survey about the post-webinar feedback and all that. And yeah, we hope to see you again. And
all
thank
right.
you.
Well, good luck. All right. Take care, everyone. Bye-bye.
Take care. Thank you. Thank you.